This right here is a difference of squares problem. The reason I know it's a difference of squares problem is I spot 9 and I spot 100 and I say those are both square numbers. I bet this is a difference of squares problem. And sure enough, it is. It's a difference of squares problem if I'm able to rewrite the problem like this. 9x squared is the square of 3x. The thing I have to square to make 9x squared is 3x. The thing I have to square to make 100 is 10. I could rewrite this problem as 3x squared minus 10 squared. The fact that I can write it like that means I can factor it into something where 3x and 10 show up in the parentheses for both factors, but in one of them it's going to be 3x minus 10, in the other it's 3x plus 10. Another example. This jumps out at me as a factor by difference of squares problem. I think that because I see a square, 81 is a square number, and I'm more positive about it because I realize I can write it like something squared minus something squared. The thing I have to square to make x squared is x. The thing I have to square to make 81y squared is 9y. So overall, this problem factors into x, 9y, x, 9y, where one of them is x minus 9y, and one of them is x plus 9y. You can write it in either order. This, what I'm writing now, is also correct. 4x squared plus 9. I look at this, I'm like, oh, 4 is a square number, 9 is a square number. But the thing is, I can't write it as a difference of squares. Here it's a plus sign. Difference of squares is for minus signs, so this does not factor. Does not factor. If I have a sum of squares, it is not going to factor. This problem, I look at this, I'm like, oh, 16 is a square number, 1 is a square number, and x to the 4 is also kind of a square number. I could write this as something squared minus something squared. The thing I have to square to make 1 is 1. The thing I have to square to make 16x to the 4 is 4x to the 2. If I do 4x to the 2 and I square it, 4 squared is 16. X squared, so x squared times x squared, that's x to the 4. So I'm good. I wrote it as something squared minus something squared. So I'm going to have 4x squared and 1, 4x squared and 1. And one of them it's going to be a minus, and one of them it's a plus. And then I say, hey, you know what? This is still difference of squares. I can factor that even further using difference of squares again. Difference of squares is going to turn this, well, this is 2x squared minus 1 squared. So difference of squares means I could do 2x minus 1, 2x plus 1 times 4x squared plus 1. The reason I factor this further is because I can factor it further. The reason that I don't factor this further is because it doesn't factor further. It's sum of squares. We just said sum of squares does not factor. This one, it doesn't look like difference of squares, but it is. It's difference of squares because before I do any factoring, I always look for a GCF. In this case, my GCF is 50, and it leaves me with 4x squared minus 1, which we just did. We said that that's 2x squared minus 1 squared. So the 4x squared minus 1 part turns into 2x minus 1, 2x plus 1. This turns into this. But I do still need this guy. I do still need to write 50 in front of it.